Hi, this time I'm going to talk through the answers to a double award science paper. It's the Chemistry Unit C1 higher tier paper, and that's for the CCEA double award science. So question 1 is asking you to complete a table showing the colours of universal indicator and the pH of 3 solutions. So the 3 solutions are lemon juice, baking soda solution and cleaning fluid. And it's giving you the colour of the universal indicator for lemon juice is orange. So the pH there they would have accepted between 3 and 6. For baking soda solution the pH is 9 and the acceptable colour there was blue-green. And for cleaning fluid, which is purple, the pH could have been 12, 13 or 14, anything in that range. So part B, from the table above, choose a solution which is a weak acid. So lemon juice fits the bill there. And the important thing here is if you're asked to choose something from the table, only write something that actually appears in the table. Part B, a weak alkali, so baking soda. There's 2 alkalis, the baking soda and the cleaning fluid, but the baking soda is of course the only weak alkali there. So part C, copper 2 oxide reacts with sulfuric acid in a neutralization reaction to form copper 2 sulfate and water. Write a balanced symbol equation for the reaction between copper 2 oxide and sulfuric acid. So copper 2 oxide, if we just have a look at how we write the formula here. So copper in copper 2 oxide has a valency of 2, oxygen's group 6, so its valency is 2. If we swap over the numbers there and write the valencies, or write it using the valencies, then that would be Cu2O2. Because those numbers are the same, just like in maths, you can cancel them out, so the formula is CuO. So the copper 2 oxide plus sulfuric acid, CuO and H2SO4, and there's 1 mark for getting that side of the equation correct. And the other mark here, there are 2 marks. The other one is for writing CuSO4 for copper sulfate and H2O for water. So that's where the marks come from. And remember, you have your data leaflet. You can look up the elements on that if you're not sure. Anything with a number in Roman numerals tells you its valency. Okay, so then describe what you observe happening during this reaction. So observations are anything you can see, you can feel, you can hear. So the first thing is that the black copper oxide, and there's 1 mark for mentioning the colour of it, reacts with the colourless sulfuric acid to give a blue solution. So the colour change there from colourless to blue. And remember, don't write clear, always write colourless if there is no colour. And then the solid disappears would get you a mark, and heat given out would be another mark, a maximum there of 3 marks for those observations. Next, copper sulfate can be produced by the reaction of copper 2 carbonate with sulfuric acid. Describe 2 ways in which the reaction of the copper 2 carbonate with sulfuric acid is different to the reaction of the copper 2 oxide. And you see there are 2 marks for this. So 2 ways, 2 marks. And you can see here there's a number of points. I've made 4, but any 2 of these would get you 2 marks. So the first observation could be that copper carbonate is green. Don't just say it is green, you have to state what it actually is. Then copper carbonate reacts more quickly, could be a second observation. Fizzing bubbles or gas formed with the copper carbonate, and then with copper oxide it needs to be heated before it will react. So any 2 would get you 2 marks. Then sulfuric acid is described as a strong acid. Explain this term. So what they're looking for is why it's strong and not weak, and the reason is that it's fully ionized in solution. If it was a weak acid and you had to explain that term, you would say it was only partially ionized in solution. Number 2, graphene is an allotrope of carbon. It consists of a single layer of carbon atoms joined together by covalent bonds. So we've got carbon atoms joined by covalent bonds. It's 200 times stronger than steel. It conducts electricity as efficiently as copper and is a good conductor of heat. And it's almost completely transparent with possibly the highest melting point known. The first question here says, explain what is meant by the term allotrope. So you need to say 2 things here for 2 marks. They are different physical forms of the same element in the same physical state. Okay, don't be going into about neutrons or anything like that. That's isotopes. Allotropes are different physical forms in the same physical state. So in this case, different forms of solid carbon. Then using the information in the passage, label A and B in the diagram of graphene below. So at the start of the paragraph here, it says it consists of a single layer of carbon atoms joined together by covalent bonds. So I've just written these in place. A is a carbon atom, and that's each of the little dots there, and then the covalent bonds are the bonds joining them together. So then in C, graphene was discovered in 2004. It has many outstanding properties. Choose one property of graphene from the passage above and suggest a use based on the property. So there were a number of properties. It talks about it being stronger than steel, a good conductor of heat, an efficient conductor of electricity, transparent and high melting point. So really it's just about picking any of those properties and suggesting a use. So I've said it's strong, so it could be used for construction. And there's 1 mark for answering both parts there. And finally in D, explain using the information in the passage why graphene could be considered to be both a metal and a non-metal. So looking at the information in the passage, it tells you that it's a good conductor of electricity like copper, or it's as efficient a conductor of electricity as copper, and also a good conductor of heat. So 1 mark maximum for the properties of it could be considered a metal. And then for non-metal, you could say carbon is non-metallic. Don't just say it's an allotrope of carbon. That doesn't explain anything. But by saying carbon is non-metallic, that's explaining how it could be a non-metal. Also, it's transparent, it has a high melting point, and it has covalent bonds. Could all mean that it is a non-metal. So 1 mark for the metal and 1 mark for the non-metal point there. Number 3, hot magnesium metal will burn in chlorine gas to form magnesium chloride. Complete the diagrams below to show all the electrons in a magnesium atom and a chlorine atom. So if we look at magnesium first, you know that it has 12 electrons. If you're not sure about that, look it up. Its atomic number is 12, so that means it has 12 electrons as well. So 2 in the first shell, 8 in the second shell, and then 2 in the outer shell, so 2, 8, 2. Chlorine, when you look at your periodic table, it's number 17, so 17 protons and 17 electrons. So 2 in the first shell, 8 in the second shell, and then 7 in the third shell. And remember to draw them in pairs where you can, because it makes it easier for the examiner to see what you're doing and to mark it. And explain fully in terms of electrons how the atoms of magnesium and chlorine react together to form magnesium chloride. Include in your answer the charges on the ions and an explanation of how the ions are held together in the compound. So, first thing you're going to explain how the ions form. So magnesium loses 2 electrons to give you magnesium ion Mg2+. So stating that it loses 2 electrons would be 1 marking point. And the formula for the ion would be another. Chlorine gains 1 electron is 1 marking point, and the chloride ion Cl- is another point. Forms magnesium chloride MgCl2 would be another marking point, just for stating that formula. And then the idea somewhere in your answer that each magnesium needs to react with 2 chlorine atoms, and each chlorine will take 1 of the 2 electrons that magnesium gives away. That's another point. And then finally, the fact that the magnesium ions and the chloride ions have opposite charges and are attracted to each other, and that they're held together then by electrostatic attraction, which is an ionic bond. That's another point. So the way this was marked, in the top tier, if you had 6 or 7 of those indicative points, you would get 6 marks, as long as you're using the special scientific terms like ions and atoms correctly. If you had 4 to 5 indicative points, you got 4 marks, and if you got one between 1 and 3, you would have got 2 marks. Next, using a dot and cross diagram, draw a molecule of hydrogen. So dot and cross, make sure you're doing one with dots, one with crosses. And I've drawn this circle here with an X on it, and this one here with a dot on it, and I've written both H's in the middle, just to be clear that they're both hydrogens. Now name the following. The bond between atoms of hydrogen atoms in a molecule of hydrogen is a covalent bond, and the force between neighbouring hydrogen molecules is van der Waals. Then we've got ammonia question. So ammonia is a compound which exhibits the same bonding type as hydrogen. So we've already said that that's covalent bonding. So using a dot and cross diagram, draw a molecule of ammonia showing the outer electrons, or showing the electrons in the outer shells only. So ammonia is NH3. Now that's one that you should know from the course, and I would recommend that you learn those. Ammonia, the hydrogen one, HCl, water, methane, and so on. But ammonia seems to come up quite a bit. So we have the nitrogen here, which has 5 electrons in its outer shell, and then we have each of the hydrogens here has 1 electron in its outer shell. And you'll see that I've written N in the middle, the big one, and H in the smaller ones for the hydrogen, and not showing any of the inner electrons for nitrogen. And then on the final bit there, on the diagram, label a lone pair of electrons. So this group here is a lone pair, okay, and I've just circled them and labelled them. Explain why ammonia has a low boiling point. Well, there are 2 marks here, so for the first mark you need to be explaining that it's a molecular covalent substance, so the forces between the molecules are van der Waals. And then for your second mark, that because it's van der Waals, you only need a little energy to separate the molecules. There are no strong there are no strong bonds between the molecules. Number 4, the question is about relative atomic mass, relative formula masses, and using mole calculations. So barium sulfate can be produced by reacting barium nitrate with excess sodium nitrate. And here we have the equation for that, BaNO3 twice, and Na2SO4 gives BaSO4 and 2NaNO3. Calculate the relative formula mass of barium sulfate. So with the barium here is 137, sulfur 32, oxygen is 16. So we've got 1 barium, 1 sulfur, and 4 oxygens. Add those together, you get 233. So, and the 64 here, in case you're wondering, just comes from 4 16s. 4 16s are 64. Then calculate the relative formula mass of barium nitrate, and again it gives you barium's 137, nitrogen's 14, and oxygen's 16. So we've got 1 barium here, so that's 137, and then this whole NO3 group has 2 lots of it, 2 outside the brackets. So 2 N's, 2 nitrogens, 2 14s, 28, and then 6 oxygens, 6 16s is 96. Add those together, we get 261. Then calculate the number of moles of barium nitrate in 13.05 grams of the compound. So number of moles is mass divided by the formula mass. We're putting in 13.05. You've worked out the formula mass in the last question is 261. We put that in, we get 0.05 moles. Then use your answer to A part 1 and A part 3 in the previous page and the equation below to calculate the maximum mass of barium sulfate that can be obtained from 13.05 grams of barium nitrate. So the 13.05 grams of barium nitrate we saw in the last was 0.05 moles. So 0.05 moles of the barium sulfate. So I think I said sulfate for the last one, the nitrate I was talking about. So 0.05 moles of barium sulfate, anyway, it's a 1-to-1 ratio, would be 0.05 times 233, which is 11.65 grams. And the final part of the calculations then, when the reaction of A part 4 was performed and completed, only 10.5 grams of barium sulfate was obtained. So you immediately know this will be a percentage yield question, so calculate the percentage yield. So percentage yield is the actual yield divided by the theoretical yield times 100. So the actual yield here from the question is 10.5. Theoretical yield from the previous part was 11.65, and times 100 gives us 90.1%. And give one reason why a yield of less than 100% was obtained. You get a loss in the separation or a loss in transfer, or you could say the reaction was unfinished. Any one of those will give you your mark. Now if we just go back to the front page of this, you'll see that there are 70 marks for this paper, And I know that people get a bit worried about the calculations. So looking at these calculations, you see here that there's a total of 1, 2, 3, 4, 5, and then I suppose if we count that, 6 marks. So 6 marks out of 70. And in fact, if you even said 5 out of 70, it's not really a huge amount. So if you are worried about the calculations, try not to panic about them when you see them in the exam. If you need to, leave it and come back to them at the end. But just do your best to work them out. And remember that there will be marks for an error carried forward. So for example, if you got the theoretical yield wrong here and used the right equation but the wrong thing, it's likely you would get an error carried forward. They're not going to penalise you twice for the same mistake. So moving on, question 5. The element carbon has 3 naturally occurring isotopes. It tells you carbon 12, carbon 13 and carbon 14. Draw a labelled diagram of an atom of the carbon 13 isotope showing the number and position of the protons, neutrons and electrons. So what I've done here is try to give a little bit of a key as well as I've gone. So I've said X equals electrons. I've drawn the nucleus here in the middle, and in it I have said 7 neutrons and 6 protons, and I've shaded the neutrons in blue and the protons in red. And then we have these electron shells, and I have the correct number of electrons, which is 6. So 4 marks for that, and that you have to be explicit in what you're saying. You can't just say the nucleus containing protons and neutrons. You need to say how many of them there are, because it says show the number and the position. Okay. Then explain why an atom of carbon 13 has no electrical charge. Well, it's because there are 6 protons and 6 electrons. So we have plus 6 and minus 6 from those two particles respectively. So because there are equal numbers of protons and electrons. So the total positive charges and total negative charges cancel each other out or add to 0. So a little bit of an explanation as to why, and then the fact that they do cancel out and add to 0. That gives you your 2 marks. So then chlorine is another element which is naturally occurring isotopes, chlorine 35 and 37. They exist in a 3:1 ratio. Show that the relative atomic mass of naturally occurring chlorine is 35. So you probably have done this in class as a worked example for this. And you know that relative atomic mass is the mass of the first isotope times the abundance of the first isotope, plus then the mass of the second one times the abundance of the second one. And you can keep doing that for the third and fourth and so on, and then divide it by the total abundance. Now in this case, you could do it as 75% and 25%, as you probably have been shown in class, but you've just got a 3:1 ratio. So I've taken the ratio of 35 as 3, the abundance, and the abundance of 37 is 1, and the total abundance then is 4. So I've got the chlorine 35 is 35 times 3 for the mass times abundance, then the 37 is 37 times 1, add those together and divide by 4 and you get 35.5. So for showing your working, you're getting 2 marks. Number 6, the modern periodic table of elements has been developed over many years. Mendeleev is credited as being the scientist who made the greatest contribution to the development of the periodic table. So outline 3 features of Mendeleev's periodic table. And you know, folks, that this comes up very often, so it's worth learning all of these. Okay, it may be as 2-3 mark questions like this, or sometimes it comes up as a 6 mark question. So outline the 3 features of Mendeleev's periodic table. So you could have any of these. So it was in order of atomic mass increasing. He left gaps. The groups were vertical columns with elements with similar properties. He had periods which were horizontal rows, and he predicted the properties of missing elements. Any 3 would give you 3 marks, but a maximum of 3. Then describe 3 ways in which the modern periodic table differs from the one proposed by Mendeleev. So again, maximum of 3 here, but you see I have 4 points you could use to get your marks. So it's in order of atomic number. We include the noble gases in the modern periodic table. There's also a clear division between metals and non-metals, and some of the groups are named. Question 7. An experiment was set up to investigate the displacement reactions of halogens. Solutions of sodium halides were prepared and reacted with other halogens. And the results table is shown below. So here we have the solutions. There's iodine, bromine and chlorine. And then they're reacted with sodium iodide, sodium bromide and sodium chloride solutions. So a tick means a reaction took place and a cross means that no reaction took place. So, okay, you can see here that the iodine solution does not react with either sodium bromide or sodium chloride. But the bromine solution does react with sodium iodide. So what's happening is you're getting basically a displacement reaction happening here. So you would have a reaction between the chlorine solution and sodium iodide. Chlorine's more reactive than the iodine, so it's going to push it out of solution. And the chlorine is more reactive than bromine, so it's going to push it out of solution as well. But bromine will not displace the sodium chloride. So you get 1 mark basically for getting the 2 which are ticked and 1 mark for getting one which doesn't happen. Okay? Then state the colour of each solid sodium halide. Sodium compounds are always white, so it's white. Describe what's observed when chlorine solution is added to aqueous sodium bromide. So you have colourless sodium bromide because the white salts dissolve to give colourless solutions, and you're getting chlorine is pushing out the bromine then from the sodium bromide, so the solution will turn orange. So 2 marks there, 1 for the colourless solution and 1 for it turning orange. Then write the ionic equation for the reaction between chlorine solution and aqueous sodium bromide and include state symbols. So chlorine solution Cl2 and Aq for in solution, and the sodium bromide then we're just interested in the bromide ion, so 2Br minus, and again Aq gives the bromine which is Br2, and that's in solution, so it's Aq, and then the chloride ions 2Cl minus and it's Aq. So 4 marks for this. And typically the way these are marked is 1 mark for the left hand side, 1 mark for the right hand side and getting the correct species on each side, 1 mark for balancing, and then 1 mark for your state symbols, so in this case the aqueous. And the final question on this specimen paper was about chromatography. So it says a student investigated different coloured inks using chromatography. The chromatogram is shown below. So if we just have a look at this here, we can see there's 1 dot for A, 1 for B, C has 3, D has 2 and E has 2. So which ink samples have only 1 colour in them? Well, that is A and B because they only have 1 dot each. You need both to get your mark. Which inks are mixed to make C? So you're looking to see where these spots correspond to with the other inks. So you can see that this bottom spot corresponds to A, and then these other 2 spots both correspond to D. So A and D have been mixed to make C. Then calculate the RF value of ink B. So the RF value is the distance moved by the spot divided by the solvent front. So it's 4.3 divided by 5.6, and you find those just by using a ruler. So please make sure when you're going into a chemistry exam, you always have a ruler because you may need to measure something like this, or if you're drawing points on a graph, it helps you be more accurate. So 4.3 is the distance travelled by this spot here in B, and the solvent front then is 5.6. So the answer is 0.77.